Hi, we're students at Auburn University, and last Sunday we determined that the average braking torque on a 1x4 would be 375 foot-pounds. We're now going to use math to calculate and determine whether each board in each scenario will brake.
To determine these braking strengths, we're going to compare the braking torques of the loads applied in each scenario to the 375 foot-pounds that we previously averaged from last Sunday. There's one key rule when it comes to drawing shear moment diagrams, and it is the area between any 2 points on the shear diagram is equal to the change in the moment diagram between the same 2 points. And previously on the diagrams poster, we labeled an area A1 and A2. In A1, we took the force of 10 pounds on the end and multiplied by how many feet it was until the next load was applied, and that gave us 45 foot-pounds. Then we did the same thing from the next point and added that, and that was 80 foot-pounds, and got a total of 125 foot-pounds of torque applied to the board from our loads. And previously we stated the average braking torque of our 1x4 is 375. And when you compare these two numbers, 125 is less than 375, and therefore our board did not break. And that is also shown in our video. As you can see, with our loads applied, 10 pounds at the end and carry in the middle, or 2 feet from the end, and she weighs 30 pounds, our board does not break, so therefore our math was correct. Once again, the purpose of this video is to compare the loads applied on the board to see if it exceeds the average braking torque of the board, which we determined to be 375 foot-pounds. In our first scenario, we're going to use a cantilever situation. We're going to place 30 pounds 2 feet from the fixed end, which is actually going to be Justin's daughter, Carrie, so we needed to make sure and be safe and know that the board is not going to break. We're going to place 10 pounds on the free end. In the shear diagram, we're going to divide it up into area 1 and area 2 to determine the moment diagram. And our M-max we determined to be 125 foot-pounds, and which is less than 375, which means the board should not break. Scenario 2. We've determined that the loads placed on this beam are going to break the beam, which means they are larger than 375 foot-pounds. Here we go. As you just saw in the previous video, we stated that our board was supposed to break when the two loads were applied. And in the field, we did a rough calculation and we thought that was correct. But after coming inside and actually drawing the shear moment diagrams and doing the calculations, we determined that the board should have not broken. And this could have been done due to a couple of factors. We are using an average braking torque of 375 foot-pounds, which could have been around 350 or even less than that. So it's no big deal about that. That's a round number. And then it also could have been due to the defective board. We could have had a bunch of knots in it or something like that. So those two factors played a key role, I think, in determining whether the board was supposed to break. But as you can see on this loading diagram, this is exactly what you saw in the video. But we determined the reactions at both ends, and this is Justin right here, 195 pounds, and he is 1 foot 4 inches from the right side, and Ben is located 2 foot from the left, and he is 180 pounds. We came down here and drew the shear diagrams, and we broke them up into area 1, area 2, and area 3. And from these areas, we determined the moment diagram. And as you can see, our maximum moment is calculated at 329.04 foot-pounds. That is kind of significantly less than 375, but once again, 375 is an average. So that could play a little bit of a key role, plus the defective board might play another role in that as well. This board displays how we came about the calculations for our maximum moment. Our conditions were 2 unequal concentrated loads unsymmetrically placed, which were Ben and Justin. And to determine the reactions at point 1 and point 2, we used our steel manual and we just plugged the numbers directly in and came up with 164 pounds and 210 pounds. And as you saw previously, we broke it up into 3 different areas. And once you calculate the areas, it should come out to equal 0. And as you saw, our moment diagram rose and then it came back down to 0. And then our M-max was determined at 329.04 foot-pounds. And this was less than 375 pounds, so our board should have passed. But once again, those couple of factors came into play. But once again, we want to drive home the purpose of this video. You can take the maximum torque that the loads apply to a beam and compare that to the average braking torque of the beam. And if that is determined to be less then the board should pass or should not break, and if it is greater than, then the board should break.